is my, okay, which one?
How about the one fairly above?
This one? Okay. So I'm going to, we are trying to determine g comp f of -1. So let's write this in for a moment. So g comp f of -1, which function is the inner?
We're still dealing with the same two functions.
We don't have functions. We are given two tables. I just want to analyze this first, and then I'll come back to the tables. So we want to analyze this. So which one is the inner function? Good. So this will be g of f of -1. This is very important because I know now that this is what I have to determine first. Don't cross it out like that. I'm just making a point. Is that clear? Always have to be able to identify the inner and the outer because that's the sequence of steps. So now I need to find f of -1. Okay, let's go back. Do we have f of -1? And what is it if we have it? F of -1 is 10. When x is -1, the function is 10. Would we agree? Perfect. So we have 10. So this piece gets replaced by 10. So now we are looking to find g of 10. Are you with me, everyone? Yes? Okay. So let's look at g of 10. Do we have g of 10 in these tables?
On the right.
Yes. G of 10 equals? Careful. G of 10 equals -1. Do we all see it? It's right here. This is function g. This is a table for g. This is a table for f. When x is 10, g is -1. Is that okay? Do we need another example like this, or is it clear? Okay. Good. So I'm back to what I was doing. So we looked at composition. Okay, so let's continue with exponential functions. Ready? Exponential function f with base b is defined by, we know that, and the range, the main of the function is all real numbers, and the range is 0 to infinity. We know that. The graph of the exponential function with base b approaches but does not touch the x-axis, not the y, the x. The x-axis of the equation is y equals 0, is a horizontal asymptote. Okay, horizontal. The axis whose equation is y equals 0. And the graph of the exponential function f with base b approaches but does not touch the x-axis. So next step. Oh, here we have, yes, we haven't talked about this. So the irrational number is approximately equal to 2 point, I don't know how many decimals, 2 decimal places, 2.71. Oh, what is happening here? 2.71. You can always go back to your calculator. Here's your e right here with the division symbol, second and e, and press enter. It will tell you 2.71, but I don't know if they wanted us to round it to 2.72. It's not clear to me. Let's see. Type an integer decimal rounded to 2. Okay, it says rounded, so then I have to put 2. Okay. So again, I don't think that this is a problem that should be in this particular. I did this with my Calc 1 class, right? Not with my pre-calc class. So the fact that 1 plus 1 over n raised to n power is e. I don't think that this is a topic that we need to discuss in this class. Okay, consider the compound interest. So the formula will be given to you. Let's see how we will fill this out. Consider the compound interest formula. This formula gives the balance, okay, in an account with a principal, yes. So gives the balance, which is A, in an account with a principal P, an annual interest rate R, in a decimal form, of course, not percent, subject to compound interest paid n times per year. So this is what each and every piece or letter signifies. So, Bob, you want to write this down?
Yeah, I've seen it a lot, but I'm not gonna write it down.
So let me write it down in the notes for everyone, okay? So in the formula A equals P1 plus R over N raised to NT, P is the principal, A is the accumulated value. They call it balance, but it's the accumulated value. It doesn't have to be, it can be called balance, but we normally say it's the accumulated value. R is the annual interest rate.
But it
T.
doesn't have to be annual or normal year.
Well, most of the time, I would say it's the annual. As you see, it is the annual. The formula is created in such a way that R is the annual interest rate.
Okay.
Yeah, because all these are calculated per year, and the number of times we compound interest is also per year. So that's why it's the annual interest rate per year, and this is the number of times the interest is compounded per year. Yeah. When we talk to exponential decay and exponential growth functions, you could have something based on, you know, daily minutes or hours, minutes, days, etc., months, but not in this case. So T is time in years, and N is the number of times interest is compounded per year. Compounded. Now on Wednesday, if you'd like to bring your laptops or tablets or whatever, if you want us to continue working, I have to go and show you everything else, right? So go through the topics and also answer your questions. So if you want, we can, you know, make some progress together. I should have invited you to bring your. Okay, so let me answer the best complete the given statement. If compound interest is paid twice a year, we say that the interest is compounded semi-annually. If compound interest is paid 4 times a year, we say that the interest is compounded. Good. If the number of compounded periods increases indefinitely, it's every second if you want, we call this continuous. I don't want to click on that. There is no need. Okay. Approximate the number using a calculator. That's not a big deal. Do I need to show this? Let me show an example like this. Okay. So we have 4 raised to negative 1.6, 3 decimal places. Okay. So 4 caret in parentheses negative 1.6. I don't know why that is in here, but it is. So we have to look at it. Okay. Press enter. 0.1088, so they want 3. So it's 0.109. So 0.109. And enter. Okay, the same thing with this. What is the equation of the line shown to the right? Can anyone give us the equation? Why is this here? I don't know. Other than I'm assuming at some point in time it will become a horizontal asymptote for an exponential function. Otherwise, there is no need for this to be here. So what is the equation of this line? Excellent. Thank you so much. Indeed, y equals negative 6. Okay, what about this one? Excellent, thank you. Set up a table of coordinates for the following function, selecting integers from -2 to 2 inclusive, then use the table of coordinates to match the function with its graph. Okay, so let's decompose this function into two pieces. First of all, 6 to the x. Is the base greater than 1? If you say yes, then the function has to look like this. Is the base less than 1? Then if you say yes, then the function has to look like this. Coming from infinity and approaching 0. Or coming from 0 and approaching infinity. Which one is it? Don't look at the graphs. We're not analyzing the graphs. We're analyzing the function. I'm talking about 6 to the x. Is it increasing on all its domain or decreasing on all its domain? Yes, because the base is greater than, yes. So it's this. But now I have -6 in front of it. It does not touch x. What transformation will this be? Say it again.
Reflection.
Exactly. With respect to? Excellent. So instead of this, I would have something like this. Now I know, and only now I look at these graphs. Potential. But I think it kind of crosses the x-axis. Let's take a look carefully. No, okay, it has potential. This one absolutely not. This one absolutely not. This one, remember we had this, and it has to look like this. So what about this? The function is increasing on all its domain. And when I reflect it, this cannot be it. Okay? So it's the first one. So from increasing, crossing at one more time, from increasing and crossing at 0, 1, it has to cross at 0, 1. All pure exponential functions cross at 0, 1. And now it has to reflect. This point that was 0, 1 is now 0, -1. And this is it. This one, because the other ones have no connection to the graph or potential, not even, okay? So this is the function. But when we reflect, it would be this, which is not the case. So it's A, we check the answer, and we're done. Okay, what about 9/4? What about 9/4? Is it a number greater than 1 or less than 1? I know it's a silly question. 9/4 is more than 2. So is it an increasing function on all its domain or decreasing? Increasing. So that's all I need. There are no transformations on this function whatsoever. No. Potential? No. No. So let's take a look. Increasing on all its domain, it must cross at 0, 1. This must be it. This is decreasing. This is not, it's crossing the x-axis, has transformations in it. This one crosses the x-axis, has transformations in it. We're done, we're choosing B, and that's the answer. Okay. Use the given functions f and g in the same rectangular coordinate system. Graph them, I'm sorry. Describe how the graph of g is related to the graph of f. Has nothing to do with exponential functions. You can graph them, of course. What is the connection? I mean, the connection, there is none to the exponential functions, but let's talk about it. So the first one is -3x, and the other one is -3x minus 4. What is the relationship between these two? How do I get the second one from the first one?
Is it both 3x and then
Yes, yes,
3x
yes.
minus
So
4?
-3x and -3x minus 4.
Right.
So if this is -3x, how would I graph -3x minus 4? Because it has a negative leading coefficient, so it has to be decreasing. So how do I graph -3x minus 4?
Down by 4.
Exactly. So you will graph both First negative 3x minus negative 3x, and the other one shifted down 4. Very good. Same thing here. So I have x squared and negative x squared. But then how will I graph the second one, which is negative x squared plus 8? Exactly. What is the vertex? One more time, x squared, negative x squared, up 8. What is the vertex?
0, 8.
Comma 8. Good. Again, I don't see the connection unless it's just a preparation. Okay. Now this makes sense. It's exponential, right? So how do I graph 4 to the x plus 2? Again, is it a function that has a base greater than 1 or less than 1? Right. So it looks like this. And now I'm asked to graph the function 4 to the x plus 2. Where do I go?
Up to.
Exactly. Exactly. So absolutely not. Potential. Absolutely not. Absolutely not. But I have to convince myself. I have to look. So the original function would have crossed at 0, 1. Is this shifted up to? It's an incorrect graph. Again. Why? Because the original graph has a horizontal asymptote at 0, and they have to show the horizontal asymptote at 2. But I think the software cannot graph more than, I don't know. It's incorrect. The graph has to show the horizontal asymptote. So this is the correct graph. Yes, that's of course what we're going to choose, but it's incorrect. Of course, we choose this and we're done. But the correct graph is this, of 4 to the x plus 2, 1, 2. I have to graph y equals 2, and this point moves up 2. So this is the graph of 4 to the x plus 2.
It crosses the y-axis at 6.
It crosses the y-axis at 2. Yes. Initially, it was here. This is 4 to the x. And then it moves up 2. From 1 to 3. I know we only have 4 minutes left. I'm looking not to cut into your break. Okay, so let's see what this is. Graph the functions 5 to the x and 5 to the x plus 2. Okay, how do I graph 5 to the x first? Increasing on all its domain or decreasing on all its domain?
Increasing.
Increasing. And then how do I graph 5 to the x plus 2? X plus 2. Where do I go with this graph? It's not outside. It touches x. It's not a transformation on y. To the, careful, no, it's not to your right.
It's the opposite.
Exactly. To your left too. Okay? So, absolutely not. Potential. No. No. Okay, let's take a look. So here is the original function. It's an exponential, pure exponential. It has to cross at 1, 0. And now we are shifting this point to the left to get g. This is it, and it's the only one. And that's b. Okay. Yes, I know, it's okay. Okay, that's okay. Same thing. We looked at this similar example. Okay, so I know we have 2 minutes left, so this may take a little bit more than 2 minutes. Let's see what is left is here. Okay, we need to work on these problems. Yeah, so I'm making myself a note. So this was which So it was not, what am I doing? It was not 30, so we did 30, 32. I think this is 34, isn't it? Yeah, it is, right here. So we have to finish 34, and we have 6, 8, 10, a lot. So 36, 38, 40, 42, and 44 left for next time.